Okay, so we've seen some examples of these, but I just want to make sure that everyone understands how to grab different parts of a list, including how we could have done the reverse slightly differently. So if I have a list that is the range 11, we know that that's going to be all the numbers from 0 up to but not including 11. I can then do various things. So remember, we have the start index, the end index, and the stride index. And some of these are optional, and if you don't put them in, Python will try and figure out what you mean. So if I do nothing, colon 6 with a step size of 3, it's going to know that we mean the beginning of the list up to index 6, and we're getting every third. So what happens is it gets 0, skips 3, gets 3, skips 3, and then it's at index 6, so it stops. So we only get 0 and 3 back. If you do 2 colon 9 with a step size of 4, you go from the 2nd to the 9th, and you get every 4th. Actually, both of these indexes are optional, so you can go from the beginning to the end with a step size of 2, and that's an easy way to get every other element from your list. So let's say you have some very detailed time points of your experiment, and you want to reduce it down, you want to subsample only every hour, you might do it like this. You might do nothing colon 60 to get every hour of your data set, for example. So this line is an alternative way of doing the dot reverse that we saw before. So from the beginning to the end with a step size of -1, we'll automatically get our entire list in reverse order. So if you don't like using dot reverse, you can do it this way. And you might see lots of people doing these things when they're writing code that works with nucleotides and stuff. So that the reason to write this is to get the whole list in reverse. If you wanted only part of the list in reverse, you might go from index 2 to the beginning in reverse order, and it will get 210. And most of these examples are the same. The bottom one is going to do from the end of the list to index 4 in reverse order, and so you get 10 up to 5. All of those examples make sense to people? Awesome. Okay, so the other awesome thing that Python offers that saves a bunch of code and is really cool, if you ask people why they like Python, Lambda functions might be one of those reasons, are these Lambda functions. Okay, so what Lambda functions do is define a function briefly for the context of creating some variables. So I'll show you what I mean by that. Let's say I want to calculate whether something is divisible by 3. Well, what I can do is I can do the thing we might expect. I can write a function called by3 that takes a number x, and if x modulo 3 is equivalent to 0, it'll return true or false, depending on whether it's divisible by 0 or not divisible by 0. I can then run that function by 3 on the number 9, and it will be true because 9 is divisible by 3. If I did by 3 8, it would be false because 8 isn't divisible by 3. So that's great. Now what I'll tell you is that this Lambda function does the same thing, at least in certain contexts. So if I write Lambda, I want x where x modulo 3 is equivalent to 0. What we see printed to the screen is actually something odd. It says function Lambda, and then it gives us some memory reference. But what this is a function that achieves the same thing when combined with the filter variable, the filter function, sorry. So both these do the same thing. You're just going to have to trust me for a second because we see when we run the Lambda function that we don't get anything useful out. However, when we combine it with filter, the Lambda function comes alive. Okay, so the top code is how we might filter a list using our by3 function, and the bottom code is how we can filter a list using a Lambda function. So they both do the same thing. The top one uses a bunch of code, the bottom one is all on one line. So what filter does is it takes a function and applies it to every value in a list and only returns the values where the function returns true. So for our by3 function, what that will do is go through our list and only include in the output list elements that are divisible by 3. So I define my by3 function, which we know returns true if a number is divisible by 3 and false if it isn't. I define a variable called myList, which is all the numbers between 0 and up to, but not including 16. And then what I can do is filter myList using the by3 function, and it will include all the elements where by3 is true and not include all the elements where by3 returns false. So it will try 0, and 0 modulo 3 is going to be 0, so that returns true. So 0 is included in our output list. It'll try 1. 1 modulo 3 is not equivalent to 0, so 1 won't be included. 2 won't be included, 3 will be included. So it goes through the list, creating this output list that is a filtered version of our input list. Now that's cool, but what we've had to do is define our by3 function only for the purposes of filtering this list. So oftentimes when you're filtering some input, you want to get all the values that are over some expression threshold, or you want to get all the time points that are in triplicate or something. You don't want to have to define a function that returns true in certain conditions and false in other conditions and then run the filter, because this function is only being used for filtering. So that's where Lambda functions come in. You can define a function that will filter our list that is only used in the context of the filter. So here we have achieve the same thing with one line of code. We're still using filter, so this line looks pretty similar to this line. We're still using filter, we're still calling filter on myList, and we're still printing the output. But where we used to have the by3 function, instead we can use this lambda function. We have to have the keyword lambda, and the elements we want to include in our filter are all of the x values where x modulo 3 is equivalent to 0. So that's how to read these lambda functions. We want to include x where x modulo 3 is equivalent to 0. So this x modulo 3 equivalent to 0 line has been included in our lambda function, and we're including all the x's where x modulo 3 is equivalent to 0 in our output list. So it does the same thing. It filters our input list and gives us an output list where every element is only the elements that are divisible by 3. So people like to use these because we don't like extra functions lying around. We don't like having to define a function only for a single purpose. If you can do it without doing that and just use a lambda function to filter your list, it's easier. So if, for example, you wanted to get all the gene expression values that are over a certain threshold, you might have lambda x where x is greater than threshold. And you would include all of those values in your output list. Does that make sense? Awesome. Okay, so let's see some other examples. This is a very basic example first. If I have a list of names, I can filter that list by a lambda function that only includes the names of x where x is equivalent to Simon on my list of names. And we get a list that only contains Simon. But we can build up more complicated lambda functions. So if I have a range between 0 and 50, I can filter that list using a lambda function which includes all of the x values where x modulo 3 is equivalent to 0 and x modulo 4 is equivalent to 0. Remember, the AND function will return true if both sides of the statement are true. We have the OR function which will return true if one side is true or the other one. So this will only include the values where x modulo 3 is equivalent to 0 and x modulo 4 is equivalent to 0. So if we look at what's returned, it's the sort of intersection of the 3 multiplication table and the 4 multiplication table. So you can imagine building up some fairly complicated lambda functions that return genes that are over a threshold and match some other criteria and perhaps are in some list of genes of interest. You can do some fairly complicated things all on a single line using this lambda function. Does it make sense how this list came out here? Awesome, fantastic.